Welcome to the Future of Structures podcast, where we talk to the experts who are evolving our buildings for tomorrow. And here is your host, Adam Jones.
Today we are speaking with Nick Hewson, who is the design manager at Xlam. So they specialise in the design and production of cross-laminated timber panels and buildings. So for a very long time, steel and concrete has been the preferred material for construction, and this hasn't been really challenged until now. So CLT has arrived, and in many cases it can provide a better solution to the traditional materials. It is sustainable, it is quicker to build, and can even boost productivity with some of the research in biophilic design. So in this conversation with Nick, we discuss where CLT is the best material selection. So things like building extensions, where previously concrete might have been too heavy to build with. Also fire and acoustic properties and the build-ups required for CLT. And the new high-tech CLT production plant that is going up in Wodonga. It is planned to be 60,000 metres cubed per year. And for those who are familiar with the Forte building, which is 1,000 metres cubed, this will be 60 Fortes per year, which is quite a lot of CLT going out in Australia. So I had a great time chatting with Nick. He's definitely one of the leaders in Australia when it comes to CLT. And I hope you guys enjoy it and learn as much as I did speaking to Nick. And without any further ado, here is Nick Hewson, the design manager at Xlam.
Yeah, so I graduated in 2005 from the University of Bath in the UK and started work in London. I found myself at a small consultancy called Technica, who was sort of 20 strong sort of boutique engineering consultancy. And at about the time I started there, CLT was just sort of trying to take a foothold in the UK. And it happened that the first project I was given was the first CLT project in the UK. It was a small kind of end of terrace domestic house. And I had to work pretty hard trying to understand German codes and things. And it became kind of a big part of what we ended up doing at Technica. We were sort of at the forefront of things over there. And since moving to Australia in 2010, I've worked at a few different consultancies, to Irwin Consult in Melbourne and ACOM, and starting to specialise more and more in timber. Yeah.
So you came here and you would have seen the opportunities in England with CLT, and when you came here there was not much going on in this area?
Yeah, that's right. I mean, I think I kind of realised very quickly, that there was, I was one of a sort of handful of people who'd really even heard of the material. And I think there was a big kind of pent-up desire in the market to sort of see some new forms of construction. And I think that, CLT really fitted that bill. So it's been a good niche for me to be in and really exciting kind of definitely sort of time for timber industry in general in Australia at the moment. I see a lot of parallels with the way that that the UK took it on back when I was there 10 years ago. And I think if anything, Australia is sort of paused. It's ready to really embrace that even to a higher degree than the UK did.
So what do you think are the biggest benefits of going with CLT, and what maybe differentiates it from the conventional construction types of, say, concrete and steel?
I think that there are a number of benefits with it. I think that it's a very tactile sort of form of construction. It's much more kind of immediately sort of appealing to people to when they get on a site. And you see things, multi-story buildings going up built from CLT. It's a very different feel to a building site being built in concrete. It's quieter. It smells nice. It's sort of safer, and I think that's a big part of it. I think a lot of it is the speed of construction as well. It's all prefabricated, cut to millimeter tolerances, and we can build on site very, very fast and really reduce construction time as well.
Yeah. So can you just elaborate on the speed of construction? I know is it one of the factors might be how many trades you might need on site? Is that right? Can you maybe elaborate on just the speed?
Yeah. So, and if you were to sort of look at an average concrete frame building, for example, and you've got subcontractors doing formwork, some doing reinforcement pouring. You've got some pouring the concrete. You've probably got 4 or 5 times the number of workforce on site when you compare that to a timber building, which might have a crane operator, a dogman, and 2 or 3 carpenters. So it's a very it's much less labour intensive than traditional forms of construction, it has huge advantages in terms of taking that labour off site into the factories, and where it's safer and easier to control.
Yeah. Is there any particular building types that are suited and more opportunities now because of the real fast construction?
Yeah, there are a few kind of core buildings that suit CLT really well. Any sort of modular form of residential, whether that's so medium-rise apartments, hotels, student accommodation, tends to suit CLT really well. Lots of repetitive floor plans suits the material, so it means we can build a lot faster. Other projects which where we have short construction programs, it might be things like schools, for example, where you try and build all the heavy structural work out of normal school operation hours. Other things where the CLT as a material, it's 20% of the density of concrete. So any buildings where you've got restrictions on the weight, where that's a big limiting factor, that might be because you've got poor ground conditions. It might be because you're building over an existing building. It might be because you're building over a rail line or something, as we're doing a lot of grade separations in Melbourne. So there's a few kind of core buildings, I think, that we know we can be very cost effective with. Yeah,
and with the building extensions, you guys might be looking at a few of them right now, yeah, and concrete obviously hasn't been able to provide this kind of building.
Yeah. So it's, if you look around the average CBD in Australia, there's a lot of existing building stock there that might be anywhere from sort of 5 to 50 stories tall, and those buildings are in a lot of cases kind of underutilized. They were designed to support a lot greater load than often is applied on them. So we think there's a real niche market to put vertical extensions in our city and increase that density by using CLT. And the advantages being that it's lightweight and robust. It's easy and fast to build with. They're not the most easy sites to work on, those vertical extensions. So it's a very simple material to be able to construct at height. You're not trying to pump concrete up 20 stories. So it's there's a real opportunity for that sort of infill project to be a big part of our cities in the next few decades.
Yeah. And it seems like it's just another option for a building owner to, rather than knock it down and rebuild, there might be some cases where they might be better to just build on top to get that extra value.
That's right. I mean, a lot of these buildings, they've been around 50 years. They're going to be very expensive to demolish. There's a lot of B-grade office space around the city. The idea that you could put some extra levels on that could be more office or apartments or hotel, use that revenue to then refurbish your existing building and give it another 50 years of life. And I think that's a hugely kind of sustainable way to approach the regeneration of our cities.
Yeah, and that's another point you just touched on there, sustainability. It is obviously much more sustainable than concrete and steel, which is another differentiating thing, would you say?
Yeah, so for every cubic meter of timber we use, there's 800 kilograms of carbon dioxide that's basically removed from the atmosphere. So the tree takes in that carbon dioxide during its time growing, and then by turning that into a structural product, we've effectively taken that carbon dioxide back out the atmosphere and then locked it into the building structure. And it's worth pointing out at this point, all the timber that goes into our panels are all from sustainably managed plantation forests. They're all, every tree that's cut down is regrown. So it's a big part of the identity of the product, and we can offset running energy and CO2 emissions from our buildings for a number of years by using CLT.
Yeah, that's awesome. And can you go through a little bit on how CLT is made? And you guys are just opening up, or in the process of soon opening up, a manufacturing plant. So can you tell us how that goes from, say, a tree all the way to becoming a panel?
Sure. So we take in rough sawn timber boards, so they come straight from the sawmill before they're planed and sent to sort of merchants. So we get the rough sawn boards straight out the mill. We bring them into our facility where they're finger jointed together into length. So we join the timber together to create the length of the panel. They could be up to 16 meters long, the individual pieces of timber. Then they get planed. So we plane the timber down to 0.1 of a millimeter tolerance. We have to make sure that we get a very close quality control on that, because the next stage is where it goes into it gets laid up into layers, and then it goes through a glue bed. So the plant that you mentioned that we're putting in the final stages of commissioning in the Wodonga region. It goes through on a bed, on a shuttle, and gets through a glue spreader, and then each layer kind of gets progressively put on top, with each layer of timber at right angles to the one before. So we can create panels from 3 to 9 layers. So once the panels goes through the glue, then it goes into a press. We've got a large hydraulic press from a Slovenian company called Laminated. It's a sort of top of the line press, and that the panel sits in there under pressure and then cures, and the whole curing process takes around 25 minutes. Once the panel is cured, then it goes into what we call a CNC machine. So it's a computer numerical control. So it's a pretty fascinating bit of kit. If you ever have an opportunity to look at one, it's like it's a large room with lots of robot arms and saws and drills and routers on, all controlled by computer, that then cut the panel that we've made into the exact shape, cuts out windows, doors, service penetrations, routes, details into it. So everything kind of controlled by computer to millimeter accuracy.
Awesome. And it's moved straight from the CAD straight into the CNC machine, right?
Yeah, so the timber I sort of see as the most kind of BIM ready structural material there is. We are able to kind of take models almost directly from the architect and design team with a little bit of post processing. Then we can turn that into a machine file that the computer understands and controls all the elements of the robot arms and cutting material, cutting cool. Heads.
Yeah, definitely. So what about the structural properties? And we'll try and not lose the architects who are listening. Just an overview of, say, the structural properties of timber and where it might be more appropriate and how it might work differently to a concrete or steel building. Yeah.
So timber as a material is it has a very high strength to weight ratio. It's sort of comparable with steel in if you express it in certain ways. So it's like I said, it's 20% of the weight of concrete, and it can be even stronger in certain applications. Timber itself is it's a difficult comparison to make because timbers has different properties in different directions, and the way that we glue our panels together, it makes a kind of direct comparison difficult. But as a general rule, we should be able to kind of match precast concrete panel thicknesses or thinner. We're where we sort of see a limit as far as structural capacity for walls and things. We're probably limited to around about 15 stories at the moment with the sort of timber that we have available. So if we want to build buildings higher than that, we're probably looking at more hybrid structures and involving steel or concrete in there in some way.
Cool. So up to 15 stories of just timber, and
That's
and
right.
then above that you need a concrete core or something like this.
Yeah, you might need a concrete core, or maybe you put steel columns in, or maybe the timber elements make up a proportion of it, but it'll be more and more difficult to make the whole building out of timber once you get above that.
Yeah, definitely.
At the moment, there's more technology coming in. There are other engineered timber products out there that are kind of coming up with greater and greater strength. So, it wouldn't surprise me in my lifetime to see that number push up to 30 or 40 with the pace of innovation in timber at the moment.
Yeah. So just quickly, can you elaborate a bit further on some of these new engineered products and how it might be different? Because, to me, timber is timber, and some people just, timber's properties maybe are what they are, but, where are some of the innovations that might be coming?
I think, there are products like, LVL, which I guess people might be familiar with, which means it stands for laminated veneer lumber. That's made, it all belongs to the same sort of family of engineered timber. And when I say that, I mean timber where we take a log, we split it into smaller constituent parts and then glue that back together. So CLT is a form of that, where we use kind of larger boards, but there are other forms like Xlam and LVL, plywood, for example, which use kind of different forms. And what engineered timber does, I suppose, is it takes the natural variability of a log, which might have defects and areas of low-grade material in, and by sort of taking the log into parts and gluing it back together, what you end up with is a material that kind of takes away all that natural variability, and it takes away the effect of a knot or a defect and spreads it across the whole beam. So it means you can rely on much greater structural properties. So there are LVL beams out there that are coming up with strengths of 50 MPa plus, so that's comparable with concrete.
Yeah, definitely.
So I think, as the timber industry starts to grow and we start to see more mass timber buildings, we'll start to see more innovation in that space and use more kind of composites of material. So I could foresee a time where we have sort of a composite LVL CLT where we use kind of higher grade materials to reduce the overall cross section to really target the timber to where it kind of does gives the most benefit. Yeah,
definitely. And you were just saying how, like, on the log, it seems like you can maybe use some parts of the log that might have been thrown out or to low value uses, you can actually now use for a high value structural use where there's defects. Or is that more or less accurate? Or
to an extent. So yeah, like I say, if you have an average timber joist, if that has a knot somewhere in it, then the strength of that piece of timber is governed by that knot. If you've got 10 pieces of timber all next to each other, the chances are, if they're glued together, the knots aren't all going to be in exactly the same place. So you take that one piece that was downgrading the whole log by spreading it across the whole section, then you've got something that's statistically a lot stronger.
Yep. So you've mentioned for vertical elements or for walls, you might get up to 15 stories. For floors, what do you see as governing the design most of the time? Is it strength or deflection or acoustic?
So there'll be a combination of factors. It's very rare to find a CLT floor that'll be governed by strength. Yep. Most of the time it will be governed by serviceability design, which means deflection of the panels and also vibration of the floor. As timber floors get longer and longer, timber is relatively lightweight, so it is more susceptible to vibration, and it needs a more careful design to make sure that you don't end up with floors that are otherwise bouncy. The other issue might be around fire exposure. Is often another thing that governs the design. So to achieve the sort of pretty stringent fire regulations we have in Australia, we need quite a lot of timber to be able to provide that fire rating.
Yep. And that extra bit of timber how does that protect or how does that provide the fire rating in itself?
So timber sort of has a really interesting performance in fire, and CLT in particular. So what happens when a piece of timber burns is it forms a black layer on the outside, which we call the char layer. And as the timber burns, that char layer kind of remains on the timber, and it gets thicker and thicker, and it actually insulates the timber beneath it. So when we're talking about mass timber buildings, when we're talking about large format glue lams and CLT, the analogy I like to draw is to one of a campfire. When you think of fire in these buildings, they have a totally different performance to kind of what you might imagine. And if you're looking at the timber frame construction, that's like your kindling and the small sticks that you put to start your campfire. They burn through very quickly. With mass timber, with CLT and glue lam, because they're such big sections, as they burn through, they form this char layer which insulates the timber below, and it can burn at a relatively slow rate. Yep. And it can give you quite long fire exposure. So, after a fire, you can you could cut through the section and see that large portion of the floor or wall is still kind of undisturbed and hasn't been affected. It's a very good insulator in that respect.
Yeah. So with acoustics as well, what kind of build up do you normally need to have for I guess the walls? And
so typically, the acoustic performance is in a large way related to the mass of the wall or the floor. So as I said earlier, timber is relatively lightweight, so we do need to compensate for that when it comes to acoustics. For an average party wall, if we were trying to design something that was code compliant to the BCA, we'd be putting a CLT wall with direct fix 16 millimeters of fire rated plasterboard, and then typically we'd need to comply with discontinuous construction requirements for a party wall. So there'd be an independent stud and another layer of plasterboard.
Yeah.
So sort of overall wall build-up of sort of 200 millimeters or thereabouts. And that would typically be able to get us, to a point where we'd be compliant with the BCA. And then greater performance, we kind of need to add more layers into the system, increase cavities and the like.
Yeah, awesome. So there's a lot of excitement in Australia at the moment about CLT. How popular do you think it will get? Do you think it'll keep trending in this direction and really take a chunk of the market from concrete?
I really hope so. I think that it's certainly, it's never going to be the dominant construction material in the market. I think there are certain areas where, to me, it seems like a no-brainer. I think we can be the majority of the market for sort of vertical extensions. I think that we really ought to be doing a lot more schools in timber. If I look around Europe, the vast majority of CLT projects that have been built there are schools and education buildings. There are benefits there in terms of the speed of construction, but also the internal environment. There's studies show that the children learn better, they're calmer and more engaged when they're in timber buildings, and I think Europe has kind of embraced that, and I'd like to see Australia do the same. I think that there's every chance that our plant could be very, very busy for the foreseeable future. And there's enough timber feedstock around in Australia that's currently kind of being underutilized that could support more plants as well.
See, I was going to ask that. So we're not really supply constrained of the actual timber to the point where it'll become, if it becomes too popular, it actually becomes unsustainable. So you don't see it getting to that point.
I can't see it getting to that point. Like I said, I think it's about we currently in Australia we do import a lot of frame material from overseas. The advantage of the CLT is being able to use some of these other elements that aren't kind of being used for structural framing. It's short lengths of timber which we can't sell. So by finger joining those together and turning them into a structural panel, then we've then kind of created some value there. So I think there's a lot of timber out there that we could use for these products.
Awesome. And for the final question, something more generic, and it doesn't have to be anything to do with structural engineering, but what do you think will have the biggest impact on the buildings industry in the future?
Look, I'm really excited by the potential of BIM and some of the technology that's coming in. We're already starting to research things like VR and AR and what sort of impacts they can have. I think that the construction industry is been very slow to adopt some of these new technologies, and having sort of experienced a number of different projects of different sizes and different materials in Australia, that there's a lot of room for improvement. And I think the technology that's available to us now is going to really drive down costs, improve speed and quality, and I think in the next 10 years, I think that technology is really going to start to mature and pick up pace.
Yeah, definitely. I spoke to Shane Scranton, who's the founder of Iris VR, on the podcast a few months ago, and it sounds really exciting. They were even talking about going into virtual reality and then using artificial intelligence to do the design with you once you're in virtual reality. And I know it all sounds like science fiction, but who knows in 5 years' time? So, yeah,
it's fascinating. I think I can. So we model everything in 3 dimensions, but we still produce 2D paper drawings at the end of the day for site. And I think we've got to get to a point where, we can have models loaded into a pair of AR glasses or something, and that people can be, walking around on site setting out panels as they go without needs for paper drawings and tapes and things. And it'd be pretty... a pretty brave new world.
Yeah, unreal. So if people want to find out more about you or Xlam, where should they go?
You can go to our website, www.xlam.com.au, or if you want to engage with me personally, you can find me on LinkedIn, Nick Hewson at Xlam. We'd be more than happy to speak to people about the technology and the potential of it.
Hey guys, Adam here. Just before you go, just one quick request. If you're enjoying the show, please leave a review. It helps our rating and ranking on iTunes, so more people can hear from the people who are making our cities better places for our future.